Alright everyone, so today we will be studying the third chapter of O level in IGCSE Computer Science, which is called hardware. So you can see that we will be studying topics such as the CPU, and we will be covering the fetch, decode, execute cycle in detail along with a few other things. So let's get started with the CPU. Alright, so many of us may have already heard about CPU, right? So CPU is basically the brains of the computer, right? This is where the actual processing of the instructions and everything else happens, right? So we will study this in a little bit of detail, right? So coming down to the role of the CPU, the first role is obviously to process instructions and data, right? So if we are, let's just say we are using a computer, right, and we are playing a video, right? So all the processing behind it, right, sending the signals to each of the pixel on the screen, all of this is basically happening inside the CPU, right? It is managing all of the actual processes and tasks that need to take place in order for us to actually play the video. So the basic task of a CPU is basically to perform instructions, right? Perform actions and process instructions. And then you can see that I've mentioned the fetch, decode, execute cycle, right? So this is basically the process, the step-by-step process that a CPU is using to process instructions. All right. So we will cover this in great detail a little bit later on. So I'm just going to skip this for now. All right. So last but not the least, the CPU consists of the control unit and the arithmetic logic unit. Alright, so there are two basic parts of a CPU. So the control unit is basically directing the operations of the CPU by fetching instructions from the memory, decoding them and managing the execution cycle. Alright, so this is basically where the fetch, decode, execute cycle is taking place. And then secondly, we have the arithmetic logic unit, right? So this is the place where the actual calculations and logical operations are taking place, right? So the control unit is basically just managing all of the instructions and the processes, whereas the arithmetic logic unit is carrying out all of the instructions. All right. So coming down to the key components of the CPU. So the first key components that you need to know about were obviously the control unit and the arithmetic logic unit, right? However, there are a few more that you need to know about. The first of them is register. All right, so we have discussed register a little bit before as well in chapter 1, right? So this is basically just a temporary data storage where the CPU stores data that is being used by the CPU. All right, so all of the memory that needs to be used by the CPU or while it is being used by the CPU is stored in registers. All right, all the data is stored in registers. Secondly, we need to discuss about buses. All right, so there are three basic kinds of buses inside a CPU, right? So buses are basically just the connections between the components of the CPU. All right, so the first one is called the data bus. All right, so the data bus is actually just transferring the data between the CPU and its components. All right, another thing that you need to know about each of these buses is the types of direction flow. All right, so this one is actually bidirectional. This means that the CPU is sending instructions and also taking instructions using the data bus. All right, so the data bus is actually being used to and fro. All right, next we will be discussing the address bus. The address bus is just carrying the memory addresses of data that the processor needs to access. All right, so this bus is actually a unidirectional bus, right? And this means that the data will only flow in one direction, which is from the CPU to the components. And the last bus is the control bus, right? This carries control signals sent by the CPU to components of the computer and vice versa, right? So if the CPU is sending signals and taking signals as well, this means that this is bidirectional. So the control bus and the data bus are both bidirectional, whereas the address bus is actually unidirectional. All right, so remember this. Coming down to the third thing that we need to discuss, which is a core, right? So a core is actually just the individual processing unit within a CPU. All right, if there are more cores, obviously more tasks can be performed at a time. Therefore, the CPU will be relatively faster than a CPU that has less cores. All right. Next, we need to learn about cache. So a cache is basically just a small amount of high speed memory located within the CPU, right? So a larger cache size will also mean that more data can be stored close to the CPU, right? So a cache is basically readying all of the instructions that need to be carried out, right? And this will basically mean that a CPU will have a relatively faster access time to the data that it needs to process next, right? Therefore, having a larger cache will basically mean that a CPU can perform instructions more quickly. Coming down to clock speed. So the clock speed is basically indicating the number of cycles a CPU can perform per second. It is measured in hertz. Alright. So the clock speed is basically, you may have heard that the processor in your laptop has, for an example, 3.7 gigahertz clock speed, right? This means that it is performing 3,700,000 cycles per second. Alright. So this is basically the number of cycles that CPU can perform per second. Also, this will also be faster if we have a higher clock speed. If the processor can perform more cycles per second, or if it has higher clock speed, it will be quicker, right? Therefore, higher clock speed basically means that a CPU will be faster. Alright, so coming down to the von Neumann architecture, right? So this is basically just a general layout of the CPU, right? These are all just registers, the program counter, MAR, MDR, all of these are basically just registers inside a CPU. And this will basically just be a description of how each of these registers are performing different tasks, right? So first of all, I've mentioned the program counter. Alright, so the program counter will basically hold the address of the next instruction to be executed. Next up, we have the memory address register, right? So as the name says, this will basically hold the memory location of the data that needs to be accessed. Alright, now we will move on to the memory data register, right? So this will hold the data that is required to carry out the process. Alright, and then next up we have the current instruction register, right? So this will hold the instruction that is currently being executed. All right, and then last is basically the accumulator, right? So the accumulator is basically holding all the intermediate results of arithmetic and logical operations. So we will actually perform some instructions that are actually happening inside a CPU by using a table later on. However, we do not need to do it right now. Just follow my sequence. Alright, so coming down to the fetch, decode, execute cycle, right? So these are basically just three stages that a CPU goes through when it is carrying out an instruction. Alright, and this is basically just a simple layout of how each of these registers that we discussed before are carrying out the task, right? And not just the registers, obviously we will be using address buses and RAM, so on and so forth. All right, so first of all, during the fetch stage, the program counter will hold the address of the next instruction. Then the memory address register will be carrying the address from the program counter, right? So the instruction that we need to perform now, it will load the address into the MAR, right? So next we need to actually use the address bus, right? So the MAR will use the address bus to send the address to the RAM, right? So if you remember that the address bus is basically a unidirectional bus, right? So the MAR can only send using the address bus, all right? And then next up we have the memory data register, right? And then basically the RAM will process all of this, and then it will send the instruction send the data that needs to be used back to the MDR, which is the memory data register. Next we will load the instruction from the MDR to the current instruction register, and then last but not the least, we will now be updating the program counter, right? So the program counter will basically be sent a signal that this instruction is being carried out. You can move on to the next instruction, right? So we don't actually need to carry out the instruction before telling the program counter that this instruction has been carried out. All right, you can just increment it before as well. Coming on to the decode stage. All right, so the decode stage is basically where the instruction is read and interpreted. All right, so this involves breaking down the instruction into its operation code, right? So this is basically where all of the stuff is readied for the execution stage. All right, now coming down to the last stage, which is the execution stage, right? As I told you before, that the ALU is basically the part of the CPU that carries out the instructions. Therefore, this is the main thing that will be used inside the execute stage, right? So over here you can see that when the instruction has been read and all the data has been received, everything is ready, right? It will always send to the arithmetic logic unit, which will carry out this instruction and perform the specific actions on the data that it was sent. And then last but not the least, we will obviously be using a few of the registers, right? So over here you can see that the accumulator will basically hold the intermediate results of arithmetic and logical operations, right? Therefore, in the execute stage, the register accumulator will be the main register that is used, all right? So now we will come down to instruction sets, all right? So an instruction set is basically just a collection of all the commands that a CPU can execute, right? So now we will just study a few of its purposes, right? So the first purpose is basically that it allows the software to communicate directly with the hardware, all right? Secondly, you need to know that the instruction set basically standardizes the way operations are performed, right? So each type of process has a standard way, right? So if we have different kinds of ways to perform a simple single process, right, that may occur in some sort of inefficiencies, right? And therefore only a single type of standard way is used to perform a single type of instruction, right? So actually these are the types of things that are updated in each CPU so that it can be made faster, all right? So the way that an instruction is processed, that is actually what is changed during a CPU when we say that the Intel has brought out its next generation, the 14th generation of processors, right? So they're basically just updating all the instruction sets and increasing number of cores and making it faster, not even necessarily making it faster by increasing the clock speed, right, by just increasing the number of processes, right? Rather it is actually just increasing the efficiency of how a process is carried out, right? And then lastly, by having a defined set of instructions, the CPU can optimize the execution of these commands, as I just told you. So coming down to an embedded system, all right? So an embedded system is basically just designed to perform a specific dedicated function, right? So rather than just a simple CPU in which you can just send a few commands and then receive those things, right, you can just use it as a general purpose computer, right? An embedded system can only perform specific functions, all right? You can't just tell it to perform any kind of function or a process. It can only perform specific functions, right? For instance, a huge example is actually just a simple washing machine, right? So you can't actually calculate a huge sum on a washing machine, right? You can only use it to wash clothes and set a timer and have different modes on the washing machine. That is pretty much all that you can do. Washing machines can't actually perform other tasks that it was not originally programmed to do, all right? So that is basically just what an embedded system is. Now coming down to the next topic, which is input and output devices, all right? So we will be studying a number of devices and studying their advantages, disadvantages, and their purpose and what they actually do, all right? And we'll also be studying a few of the sensors and what type of data they actually accumulate, all right? So coming down to the first input device, which is just a simple barcode scanner, right? So a barcode scanner is just a machine that scans barcodes, all right? So we will just study the process behind this barcode scanner, all right? So the first thing that a barcode scanner does is basically it just shines a light. So if you have ever been to a checkout counter at a supermarket, you will see that they basically shine a red light onto the barcode, right? So what is basically happening is that the black bars are not reflecting any light, right? Because black color is actually just absorbing all the light and not reflecting any light, whereas the white bars will reflect all the light, all right? or most of the light. So this will actually help the barcode scanner understand the sizes of the bars. All right, so bars inside the barcode, you can see that some of them are very thin and then some of them are very thick. All right, and they have different spaces between them, right? Some have a huge space, some have a relatively small space between them. So this is basically just how a digit or letters are stored inside a barcode, right? So each of these lines will basically, let's just suppose that this is a representation of the number 4. All right, so each of these lines are basically just representing a specific type of number. All right, so now we will come down to the digital camera. Alright, so digital camera is usually included inside our smartphones, laptops, even desktop PCs these days, right? So we will just study a little bit how this works. Alright, so if you've ever seen a professional camera, right, you will see that it has a certain kind of covering in front of it, which actually opens for a small moment and then closes back, right? That is basically the aperture, right? So the aperture is basically just a cover that allows the light to stream in through the lens. All right, so that is basically called the aperture, the small cover that opens up for a small split second and then closes back inside. That is basically to allow light to stream in for a few seconds. Then this light that flows inside is captured by a sensor called a charge coupled device. Right, and then the analog to digital converter converts each pixel or each type of light that it captures into a digital value, which can then be processed by the CPU. Next up, we need to study about keyboards, right? So keyboards are also a very simple type of machine, right? So basically each of those keys on our keyboard has a small circuit beneath them, right? So when we press on a key, it completes that circuit, and when we lift our finger, it disconnects that circuit and there is no longer any current flowing through it, right? So this is how a keyboard or a computer essentially knows what key is pressed and how long it was pressed for, right? So when you press it, a circuit is completed and then it sends that signal to the CPU and that it processes it, so on and so forth, right? So over here you can see that I've included a few more details about it, right? So as we have studied before, that each of these characters have a unique code, right? So we studied about character sets before, so you need to remember that a keyboard is basically sending a unique value to that represents a specific character. All right, next we need to know that a key press is actually generating interrupts. All right, so I'm not going to explain what an interrupt is right now because we'll study it later on. So you can just remember that a key press is basically just generating an interrupt. However, you do not need to know about it in detail. Alright, so now we'll just come down to a microphone. Alright, so a microphone is basically capturing the vibrations by capturing the vibrations of a thin membrane inside it. Alright, so a sound is basically just vibrations, right? So those vibrations vibrate this thin membrane, right? And then the vibrations of this thin membrane is actually connected back to an analog digital converter, which will convert that vibration of the membrane into digital signals or binary values, and then it sends them to the microprocessor, right? So a microphone is basically just capturing the vibrations by vibrating a piece of membrane, or you can say a sheet of maybe paper or something like that. Obviously a microphone does not use a sheet of paper, but you can suppose that a membrane is basically just a sheet of paper, right? So when you speak loudly into a sheet of paper, you will see that it will move a little bit, right? So those vibrations are basically used to capture sound. Next up, we have the optical mouse, right? Alright, so if you've ever seen an optical mouse, you will see that it is basically shining an LED light from the bottom of itself, right? So it is basically just detecting movements by capturing where the reflected light has moved from its original place, right? So let me just give an example. Alright, so let's say suppose this is the surface from where the mouse is being moved, all right, where the mouse is being put and it is being controlled. All right, so let's say suppose the mouse has a light that starts from over here, right? So if it goes over here, right, it is reflected onto the surface and then it comes straight back, right? This means that the mouse hasn't moved, right? But let's say suppose that the mouse produces light over here, right, and it sends this light over here, all right, but the next time the mouse has actually moved a little bit forward, right? So the mouse has moved over here, right? So this light will basically be captured back. However, it will be captured in a different place of the membrane cell, right? So if we have this, let's just suppose that this is the photoelectric cell, right? So if the light originated from over here, right, it will actually be coming back to a different place, right? This is how a mouse actually detects movements, all right? So now we will move on to a QR code scanner. A QR code scanner is basically just scanning a QR code using the same process that I showed you before as well. Alright, so in the barcode scanner, right? So in the barcode scanner, it basically just reflects light, and the black boxes, as you can see over here as well, reflected less light, whereas the white spaces reflected more light. Alright, so this is how a QR code works as well. It is very similar to a barcode scanner. Alright. So yeah, you can actually scan this if you want to, this is for a little bit of a surprise. Anyways, moving now to touch screens. So there are three basic kinds of touch screens: resistive, capacitive, and infrared. Alright, so we will just study resistive touchscreen first. So a resistive touchscreen, as I've shown over here as well, is basically made of two flexible layers that are separated by a small gap. Alright. So basically when pressure is applied, you can see that this upper layer will meet the lower layer, right? And this will basically complete a circuit, alright? So you can say that this is actually a little bit similar to keyboard, because when we press a switch or a key, it will actually just complete a circuit. So over here you can see that this will also complete a circuit, and this sends a signal back to the processor. So this is how a resistive touch panel works, right? So you also need to know that these types of touchscreens are cheaper to manufacture, right? So if you've ever held a cheap tablet or something like that, usually they have these types of touchscreens, and you can actually feel that you have to press harder on them, and you have to press harder on them because these touchscreens require more pressure. All right, if you want to have a touch screen that has relatively less requirement of touch, right, if you need to apply less pressure, you need to use a capacitive touch screen. All right, so this is basically when a finger touches the screen and changes the local electrostatic field, right? So our fingers are basically just electrostatically charged, right? And even if it is very minor, these touch screens can capture these minor differences, right? And this minor difference is basically how a touch screen actually knows that a finger is touching the screen, right? And also, as I told you before, that if you want a more responsive screen that requires less pressure, right, you need to use a capacitive touch screen. Also, this is more commonly being used in smartphones these days. All right, it maybe was used a little bit before, it was used in smartphones, but usually now they use capacitive touch screens. So coming down to another type of touch screen, which is called the infrared touch screen. So this uses an array of LED lights and sensors, right? So basically when that light beam is interrupted, the screen knows where and for how long the touch actually took place for, right? So this is basically just a grid of lights and sensors, right? So basically these are all laser beams over here, right? So all of these are basically laser beams, and if we touch in a specific place, right, this will remove these beams. All right, so these, let's suppose that we touch over here, these specific two beams will be interrupted and they will basically not be reaching the other end, right? So let's just suppose that if it originated from this side, right, it will not reach the other side, and therefore that sensor will then tell the microprocessor, that this is where the actual touch took place. All right, so this is how an infrared touch screen works. Coming down to 2D and 3D scanners. Alright, so 2D scanner is also working in a similar way to barcode scanner. This also illuminates the document using a light source, and then it captures the light from the document, and then it sends it back to the CPU into by through electrical signals, right? So it converts the light intensity into electrical signals and then sends it back to the CPU. So this is also very similar to barcode scanners and QR code scanners. Anyways, moving on to a 3D scanner. Alright, so this is a little bit more complex. However, it is also very interesting. Alright, so if you've ever seen a 3D scanner, you will know that these scanners are basically just boxes inside of which you put the actual object that you need to scan, right? So basically what happens is that there is a grid of lasers, alright, and those lasers are basically reflected off of the object and they're captured by sensors. So those sensors basically calculate how long it took the laser to go and then come back. That will basically calculate how wide or how high the object is. Alright, so reflections of laser beams are actually used to calculate the height and the width and the length of the object. So this process is basically repeated throughout the whole object surface, and this is how those images are combined to form the actual 3D scan of the whole object. Alright, so coming down to output devices. So the first output device that we will study today is called an actuator, right? So an actuator is just a simple device that converts electrical signals into physical movement, right? So this includes multiple types of output devices, right? For instance, electrical motors, solenoids, hydraulic actuators, all of these kinds of things are basically just an example of actuators, right? So an electric motor, for example, is basically taking in electricity and producing physical motion, right? Rotating physical motion. So coming down to DLP, which is digital light processing projector, right? So let's study how this works. First of all, you need to know that it uses a lot of tiny mirrors that are laid out in a grid. Secondly, each of these mirrors is actually a pixel in the image. Third, these mirrors can tilt towards or away from the light source. So that is how they basically control which color and if they even have to show a specific pixel in the actual image that is being formed. Fourth, these mirrors reflect the light towards the lens, and then the color is produced using a color wheel, and then this is displayed on the image. This displays the image on a wall or a screen. Alright, so this is how a DLP projector works. Alright, so now we'll talk about liquid crystal display projector, right? So as the name says, this will basically just use LED backlights, right? So inside an LCD TV screen or whatever it is, they're basically just using LED or CCFL as a backlight, right? And then next we will actually utilize liquid crystal panels, right? So there will be one for red, green and blue, and this will basically form the different colors. Next, that light will be passed through the LCD panels where individual pixels can be turned on and off to create the image, and then the light is then passed through a lens to focus and magnify it, right? So the lens in every type of projector is basically performing the action of magnifying and focusing the image so that it can be seen clearly on the screen. So a few differences between the LCD projector and the DLP projector. Alright, so an LCD projector is basically more bright, it has higher color accuracy and is typically less expensive, whereas the DLP projector compared to an LCD projector is more compact and more reliable. Alright, so now we will move on to an inkjet printer. Alright, so the inkjet printer is basically performing the print cancel. Alright, so first you need to know that when the printer receives the data from the computer, it moves the head to the starting position. Alright, then the actual ink that needs to be printed onto the paper, it is prepared before the paper actually reaches the motors. Alright, so the tiny droplets of ink are formed using different types of technologies. Alright, it can either be thermal, which is using heat to create bubbles that force ink out of nozzles, whereas piezoelectric is when crystals change shape to push ink out of nozzles. Alright. Now, once the tiny droplets of ink are formed, right, those droplets are precisely placed on the paper, right. So those dots of paper are basically produced inside a nozzle. That nozzle is moved around to the precise location where those droplets need to be placed, right? And then different color inks are mixed to produce various colors. If it is a colored paper, if it is a colored printer, and then that is basically just quickly dried using a heater. Next, we will study about laser printer. Alright, so this type of printer will basically use drums or rollers to produce the image. So first of all, the drum that we have to use is cleaned. Next, a laser beam will scan the drum, discharging certain areas, right? So the laser beam is basically just used to charge certain areas of the roller, whereas others are left. So the place where we actually have to place we actually have to print something, those places are charged, whereas the other are left uncharged or discharged. Next, that drum is passed through a toner hopper. Alright, so the negatively charged toner will then stick to the positively charged areas. So the places that we actually charge using the laser, onto those parts the toner will actually stick. Alright, so the particles will then stick to the charged areas of the drums. Next, the paper is fed into the tray, and then the drum will roll over the paper. Alright, so the drum already has all the ink in the right places. It will just need to roll onto the paper so that it can print the things onto the paper. Next, it is heated so that it can melt all of the toner particles and fuse them permanently onto the paper. And last but not the least, all of the residual toner is then cleaned off the drum so that it is ready for the next cycle. Alright, so now we will be talking about a 3D printer. Right, so there are two basic kinds of 3D printers, additive and subtractive. So the additive 3D printer is basically when the printer is loaded with materials and then the model that we have to build is built layer by layer, right? So it deposits the material on top of the previous layer and keeps on hardening it, right? Whereas the subtractive type of 3D printer is when there is a whole solid block that is bigger than the actual dimensions of the shape that we have to produce or the object that we have to produce, and then that solid block is cut using different tools such as lasers or blades. Alright, so now we'll move on to liquid crystal display. So this is very similar to the liquid crystal display projector that we were studying before. So this is basically when a backlight, LED or CCFL is emitted, right, and that passes through the first polarizing filter, right. Then when an electric current is applied, the liquid crystals twist or align to allow varying amounts of light to pass through, and then we need to produce. So when we know the intensity of each pixel, we then have to produce a specific color. We have to give a specific color to the pixel, right? So it passes through color filters red, green and blue to create this specific type of color, and then that light is passed through a second polarizer which forms the visible image on the screen. Next up, we have a simple LED screen, right? So LED screens are basically just made up of tiny pixels arranged in a matrix, and then each of these pixels basically have LED lights, right? So in LCD, we are basically using a single backlight, and then we're using polarizers for each pixel to actually produce a specific color, right? However, in the LCD screen, we just have LEDs in an LED screen, we just have LEDs for each of those tiny pixels, right? So we have 3 LEDs of red, green and blue color, which are the primary colors and make up the other colors. So this basically produces the specific color for each pixel, and that is just a small example of an LED screen. Anyways, moving on to speakers, which is the last output device. Alright, so speaker basically produces sound by the back and forth movement of a diaphragm. Alright, so basically a diaphragm is moving back and forth to produce sound, right? Because sound is basically just a series of vibrations, compressions and rarefactions, right? So they are basically produced by moving a diaphragm, which is actually just a thin screen, or thin, not exactly a screen, but a thin material that moves back and forth. All right. So now coming down to the sensors, different kinds of sensors that have different kinds of inputs. All right. So first of all, acoustic sensor, right? So this is basically just used for detecting sound levels. Next we have an accelerometer. This measures acceleration forces. All right, so if you move your phone around, right, and then it changes its orientation, that is basically the work of the accelerometer, right? So that is used in smartphones for changing screen orientation, right? Next up we have the flow sensor, which basically measures the rate of fluid flow. We have a gas sensor, which detects the presence of gases, right? And then next up we have humidity sensor, which obviously measures the moisture content or the humidity in the air. We have the infrared sensor, which detects infrared radiation. We have the level sensor, which basically measures the level of liquids or solids, right? So if you want to keep something at a specific level, right, you use a level sensor to actually measure that. All right. Next we have a light sensor, which measures the ambient light intensity, and then we have a magnetic field sensor, which obviously detects magnetic fields. And then a few more sensors. First of all, we have the moisture sensor, which obviously measures the moisture level, right? And then we have the pH sensor, which measures the acidity or alkalinity, right, which is actually just the pH of the solution or whatever we are measuring. Next we have pressure sensor, which measures the pressure of gases or liquids, right? And then we have a proximity sensor, which detects the presence of objects nearby, right? And last we have the temperature sensor, which measures temperature. All right, so also make sure that you know what is this specific sensor does and where it is used, right? So know at least one use case for each type of sensor. All right, so now we will talk about data storage, right? So first of all, we will study about primary storage, right? So there are basically just two main primary storage devices that are used in a regular computer, right? The first is called RAM, all right? So random access memory is the first type of primary storage that we will study today, right? So first of all, what you need to know is that when the computer is turned off, right, the random access memory will lose all of its content, right, which means that it's basically volatile. All right, next it allows quick read and write access, right? So RAM is generally faster than HDDs or SSDs that we use inside our PC, right? Next, what you need to know is that it is used to store running applications and the operating system. Alright, so coming up to the read-only memory, right? So the ROM is basically a type of non-volatile memory that stores critical boot and firmware instructions, right? So unlike the RAM, this is basically non-volatile, which means that when the computer is turned off, it does not lose its contents, right? Next, what you need to know is that data cannot usually be written to a ROM, right? So it can be changed, however, that is very difficult to change in a regular PC, right? We cannot actually change our own ROM very easily because, if you want to load some kind of application or something like that, you can easily change the contents of RAM. However, the bootloader and the basic stuff that manages all the hardware of a laptop or a computer, right, that is not supposed to change because that may result in a lot of errors, right? So they do not allow RAM to change. Anyways, moving on, data is pre-written, right? Obviously, if you cannot write it, that means that all of the if you have a laptop, if you buy a laptop, all the BIOS, which is the basic input output system, is already stored into the firmware, right? Or it is already stored into the ROM. All right, so next up we will study about secondary storage, right? So secondary storage basically refers to storage devices that are not directly accessed by the CPU. Alright. So first of all, what you need to know is that the secondary storage retains data without a continuous power supply. Right. So HDDs and SSDs on which you store our files and other stuff basically store that data all the time, right? So when even if you turn off the computer, it will still contain all that data. Right. Next up, you can store that data permanently or for extended periods, right? So if you are using, for example, a magnetic storage device, right, that has a longer time span for storing data than maybe SSDs, right? SSDs, if you store them over long times, they may lose their contents. However, magnetic storage devices are relatively more reliable if you want to store something for longer periods of time, right? Anyways, let's just discuss magnetic storage now. So first of all, magnetic storage devices use magnetic platters. All right, so if you've ever seen an HDD, right, it basically is just a disk that is spinning at a very high speed, and it has a head, right, which is actually reading or writing the data inside the disk. All right, so there's one disk or a magnetic platter that is moving around, that is spinning at a very high speed, and then there is a head that is reading or writing the data. So these are two main parts of the HDD or just any type of magnetic storage. Next, we have next what you need to know is that it basically is using electromagnetism to polarize tiny regions of the platter to represent binary data, right? So if a specific region has been polarized, that means that it is representing 1. If it hasn't been polarized, that means that it is representing 0. All right, so this is how data is stored on HDDs. Anyways, moving on to optical storage, right? So CDs, DVDs, Blu-rays, these are the types of storage that come under optical storage, right? So optical storage devices are basically using lasers to read and write data, right? And that laser is basically creating bits and lands on the surface of the disk. All right, so if there is a pit, that means that it represents 0, and if there is land, that means it will have 1. All right, so let me just give you an example. So let's just suppose that this, all right, let me just switch to a pen. All right, so let's just suppose this is land, and then there's pit over here, and then there's a land again, small pit, land again. So this is basically a representation of 0, then 0, 1, that is the representation 1, and then it's 0, 0, and then 0, and then 1 again, 0 here, 1 again. So this is basically just how data is stored inside a CD. All right, next up, what you need to know is that there are a few differences between CDs, DVDs, and Blu-rays, right? This is very important, so listen carefully. First of all, CDs are read using red lasers, right? And they only have a single layer. Also, CDs have the smallest storage capacity. However, DVDs have relatively higher storage capacities but are still less than Blu-rays, right? So if you have to rank CDs, DVDs, and Blu-rays in order of highest storage, right? First of all, Blu-ray will have the higher storage, then DVD, and then we will have CDs. All right, so this is in order of higher storage. Anyways, moving on to other points, right? So first of all, DVDs use a laser with shorter wavelength, right? So if the pits and lands are relatively shorter, right, that will basically mean that we can have more pits and lands, which means that there will be more storage and there will be more data that can be stored on the CD or DVD. All right, next let's just come down to Blu-rays, right? So Blu-ray uses an even shorter laser, which is a blue or violet color laser, right? So a red basically has a higher wavelength, which means that the pits and lands will be relatively bigger than in Blu-rays. All right, so because Blu-rays use a laser of shorter wavelength, that will basically mean that the bits and lands will basically be shorter or smaller, which will basically result in Blu-rays allowing for higher storage. All right, and because they have a higher density, they can store significantly more data. Now coming down to SSDs, right? So solid state storage is basically under which category SSDs and USBs come, right? So USB and SSD is basically just an example of solid state storage, and this is also called flash memory. All right, first of all, like all other storage types except for RAM, this is non-volatile, which means that it will not lose its contents when it shuts off, right, when the computer turns off. Secondly, it has no moving parts, right? So if you see an HDD, right, it has a disk that has to spin at a very high speed, and then it has a head that has to move around right? So that will basically result in a higher chance of breaking or the disk becoming unusable, right? However, because this has a moving parts, this is a little bit more reliable than HDDs, right? Secondly, you need to remember these terms, right? It can be using NAND or NOR technology, and secondly, it uses EEPROM technology, right? So you need to remember these. However, you do not need to know the actual details of this, all right? And then what you need to know is that basically this is using different types of transistors, all right? So it has a huge number of transistors inside it, which basically turn the values from 0 to 1 and then 1 to 0 depending on the current inside the transistor, all right? So basically the transistors have current stored in them, and that is basically how they represent 1 or 0, right? So this is pretty much it for solid state storage, right? Just a small comparison of HDDs and SSDs. This is also very important for the exams, so make sure that you remember these. First of all, HDDs have moving parts, but SSD does not. This makes it more reliable, right? Secondly, HDD is an example of magnetic storage, whereas SSD uses flash memory, right? Third, you need to know that HDD is relatively slower to access data than an SSD. Fourth, HDD will create noise, right? Because there is a disk that is spinning and a head also has to move, whereas SSD is very quiet and cooler because it has no moving parts, right? So these are just the few differences between HDDs and SSDs. Make sure that you remember at least 4 of them. Moving on to virtual memory, right? So virtual memory is basically the memory that is created by partitioning an HDD or SSD and setting aside that space just for the virtual memory, right? So let's say suppose that you have a RAM that is of 16 gigabytes, right? However, you need to run an application that requires 32 gigabytes of RAM, right? So because you cannot easily upgrade RAM, what you can do is basically you can just set aside some of your storage from HDD or SSD that you use for regular files. You can set that aside to be used as virtual memory, right? Which will basically just be an extension of RAM, right? So when the RAM is fully utilized, the OS will basically move pages of data that are not actively being used from the RAM onto the virtual memory, right? So that will basically free up the RAM for other active processes. Now coming down to cloud storage, right? So we've all heard about cloud storage, right? Google Drive and iCloud, these are all examples of cloud storage. This is basically when the data is not stored on the device that you're using, rather it is stored on a remote server, right? So if you've ever heard of, right, Google Drive or iCloud, right, they basically have huge servers inside huge locations, right? And they're located in places far away from where we are actually accessing the data, right? So all we have to do is basically just have access to the internet and have an account for that specific type of subscription service for the cloud storage, right? And we can easily get access to the storage, all right? So a few differences between cloud storage and local storage. First of all, cloud storage, as I said before as well, is accessible from anywhere with an internet connection. However, local storage can only be accessed to the physical location, right? So this is very convenient if you have multiple devices, right? So rather than having a single file on one type of device and then you have to transfer it to other devices to be used, you can just save it on a single cloud server and you can access it from any device anytime you want, as long as you have an internet connection, right? Also, secondly, cloud storage is easily scalable based on user needs, while local storage will require purchasing additional hardware, right? So if you have an SSD or a storage device, any type of storage device, you will basically need to buy another storage device to actually extend that, and maybe your laptop does not have enough capacity or your PC to extend memory, right? However, this is not the case with cloud storage. All you have to do is basically pay them more money and they will give you more storage. You do not have to worry about your laptop or your PC supporting more amounts of storage, right? So there's just a few differences between cloud storage and local storage. Make sure that you remember at least 3 of them. Coming down to our last topic, which is network hardware. Alright, so the first thing that we have to learn in network hardware is the network interface card. Alright, so as the name states, it is basically a hardware component that allows a computer to connect to a network, right? So this is basically just the physical interface that is necessary for the software to enable network communication. Alright, secondly, we will learn about MAC addresses and IP addresses. So a MAC address is basically a unique hardware identifier assigned to each network interface card, right? So let's just suppose you have a laptop, right? So that laptop will have a unique MAC address already stored into its network interface card, all right, or wireless network interface card, right? We will learn about that a little bit later on as well. So it will already have the laptop specific MAC address, and that cannot be changed, right? That is very unique only to that specific laptop, or that specific network interface card, and that cannot be changed, right? Also, what you need to know is that a MAC address is typically a 48-bit number, right? And the first 6 digits identify the manufacturer of the NIC, and then the other 6 digits serve as a serial number or the unique identifier for the device, right? So remember that the first 6 digits identify the manufacturer, the other 6 digits serve as a unique identifier for the device, all right? And last but not the least, obviously it cannot be changed, as I mentioned before as well. Coming on to IP addresses, right? So unlike the MAC address, an IP address can be changed, right? So an IP address is basically just a numerical label assigned to each device connected to a computer network that use the internet protocol for communication, right? It basically uniquely identifies devices on a network, ensuring that data is sent to the correct destination, informs about the device's location within a network, right? So let's just suppose you have a laptop that is connected to your home Wi-Fi, right? So it will have one type of IP address. Let's just say that it has an IP address of 111.241, right? Let's just suppose you move to your school, right, and you have to connect your laptop to your other Wi-Fi, right, which is your school's Wi-Fi, right? That will assign you a different type of IP address, right? So let's just suppose they give you an IP address as 1682, right? So this is a unique IP address this is actually a new IP address that is assigned to your school's router, and this is a unique IP address that is assigned by your home router, right? So this is basically just a small difference between MAC address and IP address, right? So IP address can change, however, MAC address cannot change. So there are two basic types of IP addresses, IPv4 and IPv6, right? So IPv4 consists of 32 bits, which is usually represented as 4 decimal numbers separated by dots. Secondly, it supports approximately 4 billion unique addresses, right? However, unlike the IPv4, IPv6 consists of 128 bits. So the difference between IPv4 and IPv6 is that it basically has more bits, and secondly, IPv6 has hexadecimal digits, right? So IPv4 had decimal numbers only, 0 to 9. However, IPv6 has hexadecimal, which is 0 to 9 and then A to F, as I told you before in chapter 1 as well. So this means that it can have virtually an unlimited number of unique addresses, all right? So coming down to router. All right, so a router is basically the device that is controlling your interaction with other networks, right? So a router is the thing that directs data packets between different networks, and it ensures that they reach the correct destination, right? So routers basically, as I told you before as well, assign unique IP addresses to each device on a local network, right? So routers, first of all, what you do is basically identify each device that is connected to the LAN network, and then when it has to send that, when the device that is connected to the router has to send a data packet to another network, it basically has a list which is called the routing table, right? And then that routing table basically stores the addresses to other networks, and then it uses that routing table to send that data packet along to other networks, all right? So that is basically just how routers work, right? Also, when a router receives a packet, right, it basically checks the packet header for the IP address, right? If it has the correct destination, for instance, if that router receives that for a device that is connected to itself, right, it will forward it along to that specific device. However, if the router receives a data packet that is not meant for itself, or rather for another device on another router, it will basically direct it to that specific router, all right? So that is pretty much the work that a router does, all right? So yeah, that's pretty much it. All right, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. also make sure that you share these with your other friends who are studying the same subject. All right, I'll see you later.